Hello everybody, my name is Jeremy. For my discussion number 10, I chose web work number 8, question number 28, where it asks you to find a possible equation for a linear function with the given contour diagram. I chose this one because I have a hard time visualizing concepts in Calc 3, and working through this problem really helped me understand how to get an equation off of a contour diagram such as this. So to start, I decided to pick a point that had points to the left and right of it, and also to the top and bottom. So I chose point 5, 6, which ended up having a z value of negative 90. Like I said, I chose that one because it's kind of in the middle of the diagram. So I have points that I can go to the right, to the left, to the top, and the bottom. So one thing to remember also is get our equation of the tangent plane, which is z equals f of, we call it x of 0, y of 0, and that'll be my starting point, plus my fx, partial derivative of that point, multiplied by x minus x of 0, and then the partial derivative fy of my point multiplied by y minus y 0. So to find partial derivatives of this point, you can take fx is actually equal of 0.56 equal to our change in z over our change in x. So I chose this point because I have points all around it that I can choose from. So I'm going to go 3 over from 5, 6 to 8, 6. F of 8, 6 minus, and then I'm going to go 3 points to the left, which would be 0.26. And then my change in x is starting at 5, 3 over, 3 to the left, so that'll be 8 minus 2. So my z values of my f of 8, 6 and f of 2, 6. F of 8, 6 is negative 105 minus the z value of my f2, 6, which is negative 75. And then my change in x, 8 minus 2 is 6. So that gives me a negative 105 minus negative 100, or negative 75 gives you negative 30 divided by 6 gives you a negative 5. And then do the same thing to find my partial derivative, fy, but instead of a change in z over a change in x, it'll be a change in y. So with this one, keep my x value the same. I'm going to go 3 up and then 3 down. So f of 5, 9 minus f of 5, 3. And my change in y was start at 9 and 3, so it'll be 9 minus 3. So my z value of f5, 9 is negative 75. And then my z value of f3, or f5, 3 is negative 105 over change in y. 9 minus 3 is 6. So that gives me 30 divided by 6 equals 5. Now take these values and I plug them into my equation of a tangent plane that I wrote up here. I'll write it again down here. So z equals f 5, 6, so that was my starting point, plus my partial derivative of that point, fx, multiplied by x minus my x value, plus my partial derivative fy of my original point, 5, 6, multiplied by y minus my y value. So f 6, look at here, 5, 6 gives me negative 90, plus my fx 5, 6, which I calculated up here, gave me negative 5, multiplied by x minus 5, plus my partial derivative fy, which I found up here, was 5, multiplied by y minus 6, and this will give me negative 90 plus negative 5x plus 25 plus 5y minus 30. And if I were to simplify that, it gives me z equals negative 5x plus 5y minus 95. And that is how you find the possible equation for a linear function with the given contour diagram. Thank you. I'm glad you can get something out of this and learn from it the way that I learned how to find that equation off of a diagram. Thank you.